Hi students. In this lecture, I am going to discuss previous year's IIT questions. Let us see first one. Let's see the question given. Given mass of the particle and its charge traveling with a velocity and direction is positive x enters a region in which uniform electric field and uniform magnetic field are present. So Ex0, E by 0, Ez minus 102.4. So here minus indicates it is along negative z direction. So along x, along y, no electric field, only along negative z direction. And coming to magnetic field, x and z both are 0. It is only along y axis. See what we have to calculate. The particle enters this region at the origin at time t equal to 0. Determine the location of the particle at t equal to 5 10 power minus 6 second. If the electric field is switched off at this instant and condition is still magnetic field is present, what will be the position of the particle at t equal to 7.45 10 power minus 6 second? Let us see how to start. So condition is having both the fields. One is along negative z and one is along y-axis. And coming to velocity along positive x. That means all three are mutually perpendicular. Let's see how to start. So first note down given data. So given mass of the particle mass of the particle, it is 10 power minus 26 kg and it's a charge 1.6 10 power minus 19 coulomb. Velocity 1.28 10 power 6 meter per second, and direction is positive x. I can write here I cap. Okay, so V bar equal to. Next, coming to electric field. Electric field, it is only along negative direction minus 102.4 kilovolt per meter, and magnetic field only along y-axis. It is 8 to 10 power minus 2 Tesla. So this is now given data. Now we have to calculate at time t equal to 5 10 power minus 6 second. We have to get x, y and z coordinates. Okay. Now see here what we can say. First of all, we have to focus what is a net force acting on the particle. Okay. Because of electric field, force will be Q into E. Okay. And because of magnetic field, force will be Q into V bar cross B bar. And you can see between velocity vector and this magnetic field vector, angle is 90. You can see velocity, it is along positive x-axis, and magnetic field along positive y-axis. Angle is 90. So modulus value QVB, that is modulus value. And direction part, this is I cap and this is now J cap. I cap across J cap, that is a K cap. So direction is K cap. And coming to electric field, it is along negative z direction, right? That means force will be along negative z axis. So minus k cap. So you can see here magnetic force along k cap, electric force along negative k cap. Okay. So positive z, negative z. And see calculation part carefully. The value of Q into E. So Q 1.6 into E value 102.4. Okay. You can see that both modulus values are same. Okay. If you make calculation Q into E, QVB, we come to know that their modulus values are equal. That means net force equal to 0. So since net force 0, velocity constant. That means it continues to move along positive x-axis with the same velocity. Okay. Now see the question. So we have to get coordinates x, y, and z when t equal to 5, 10 power minus 6. So here what I can say is coming to x coordinate, it is v into t. See how much v value 1.28 10 power 6 times 5 10 power minus 6. 10 power 6, 10 power minus 6 gets cancelled. Remaining 1.28 into 5. Okay, it is 1.28 into 5. Then see how much we get. X equal to 6.4. Okay, 6.4 meter. That means now coordinates. X value we got, y value 0, and z also 0. Because net force 0, velocity constant. So this moves along positive x-axis. That's why y and z both are 0. Right? Now see in this, the second part, if electric field is switched off at this instant, okay, at this instant, electric field is now switched off. What will be the position of the particle at t equal to 7.45 10 power minus 6 second. Okay, that means what is extra time? 7.45 minus 5, right? That is the extra time interval. Now focus carefully. It is only magnetic field. Okay, and that is along y-axis. Velocity along x-axis. So I cap across j cap. It is a k cap. Okay, let us see. This is now x-axis. Let us take now when time t equal. Let us take. I am taking this as t1. Okay, this is t2. At time t1, x coordinate 6 comma 4. Okay. Now what he's saying is there is only magnetic field. Okay. Now see carefully. I cap cross j cap. It is a k cap. So velocity along x-axis, force is along positive z-axis. That means motion will be now you can see here deflection will be force along z-axis. So I am taking this as now z-axis and this is now x. So velocity along x-axis, force along z-axis. The deflection is now like this, right? Now focus carefully at t equal to 7.45 10 power minus 6 seconds, right? So first of all, focus here. What is omega value? Okay. or let me calculate what is now time period of revolution. Time period is 2 pi into m by b. Okay. Substitute now values here. Mass is known, B is given, and Q also given. Okay. And this value, after making calculation, it comes out to be. So it comes out to be, see how much it comes? It comes out to be, it comes out to be 2 into T2 minus T1. Cross check once, okay, calculation part. That comes out to be 2 times of T2 minus T1. Okay. Now here we are focusing in the time interval T2 minus T1. That means it is a half of time period of revolution, right? It is a half of time period of revolution. That means it completes a half revolution. That means now diagram must be like this. Diagram must be like this. Okay. That means now location of the particle. This is now location of the particle. And this is now x coordinate, that is now x equal to 6 point. And this is now z axis. And this will be equal to, it is 2r, right? Twice the radius. And we can find r value, that is equal to mv by bq. That means now x coordinate 6.4 meter, that is no, y coordinate is 0, and z value is now 2r. That means now coordinates are 6.4, y value 0, z value 2r. Okay. And you can find the value of r, where r equal to mv by bq. So here all values are known. Okay. So I hope you got clarity. Let us see next one. Let's see the question given. A particle of mass m and a charge q is moving in a region where a uniform, constant electric and magnetic fields E bar and B bar are present. E bar and B bar are parallel to each other. At time t equal to 0, the velocity V naught bar of the particle is perpendicular to E bar. Assume that its speed is always very small compared to speed of light. Find the velocity V of the particle at time t. And it is given, you must express answer in terms of t, q, m, the vector V naught bar, E bar, B bar, and their magnitudes V naught, E, and B. Okay. So asked for 8 marks in 1998. Let us see how to start. Right. First, write down the given data. Condition given E bar and B bar both are parallel. And velocity perpendicular. So let us take velocity V bar. Suppose it is now, okay, it is a V naught bar. That is equal to V naught. Let us take it is now along x-axis. So I'm taking I cap. So this is our choice. Next, E bar and B bar are parallel. And condition given, velocity perpendicular to E bar. Let us take E bar. That is E into, suppose take it is now along positive axis. So check up. The magnetic field also along same direction. So J cap. Okay. Next, see what else. So it is given uniform electric field, charge Q, massism. Find velocity of the particle at time t. Right. Let us now focus how to start the problem. First focus, because of electric field, what happens? Since electric field is now along y-axis, since it is along y-axis, that means it is normal to velocity vector. Therefore, this component of velocity does not change. But because of this electric field, it gets velocity component along y-axis. That means I can write Vy is equal to Ay into T. Okay. So along this acceleration is now Eq by M. QE, that is electric force along y-axis upon mass. Acceleration along y-axis because of electric field into T. This is now y component of velocity because of the electric field. And in this component, there is no change because of this vector. Now focus because of magnetic field. Velocity is now normal to b bar, right? That means motion must be circular. So I am focusing only b bar and v bar, okay? So only because of magnetic field, it must be, it must be, it is a uniform circular motion, right? Now see what I can say here. Coming to magnetic force. So coming to magnetic force, F bar equal to Q into V bar cross B bar, V bar, V not I cap, B bar, B J cap, I cap cross J cap. I am writing here V not I cap plus B J cap. See what we get. Q V not B I cap, sorry, this is a cross. This is a cross. So I cap cross J cap, it is a K cap. That is now magnetic force. Because of this force, it follows now circular path, right? So velocity along x-axis, a force along z-axis. So just now we have discussed in the previous question. It is almost the same. Velocity along x-axis. Along x-axis. Force along z-axis. Therefore, it follows a path. It is circular path only because of magnetic field. Okay, I'm focusing only magnetic field. That means now velocity vector is having components along x and along z. Then see what we can write. Let us take at one instant. The velocity vector makes angle theta with its initial motion direction. That is x-axis. Okay. And we are knowing that because of magnetic field, speed does not change. Therefore, it remains V naught. So this is V naught. So Vx will be V naught cos theta, right? And coming to Vz, Vz will be, it is V naught sin theta, right? And see what else we can write here. In the place of theta, we can write omega t because he is asking express as a function of time. And we are knowing that omega equal to bq by m. Okay. So I can write theta equal to omega t. Omega value bq by m. Right? Now we got x component of velocity, y component of velocity, and z component of velocity. Therefore, v bar V bar is equal to Vx I cap, that is V naught cos theta cos omega t I cap plus V naught sin theta, sorry, it is a k cap, V naught sin theta k cap. Next, coming to y component, QE by M into T j cap. Okay. But question is given that we have to write in terms of E bar, B bar, V naught bar. Okay. So here what I am doing is in the place of phi cap, psi cap is now direction of velocity vector, right? Then what I can do here, you can see from here, V naught bar by V naught, V naught bar by V naught. This is what we can write in the place of I cap. Okay. Next, in the place of J cap, in the place of J cap, I can write E bar by E. So in the place of J cap, write E bar upon E. Because he's asking in terms of V naught bar, V naught, E bar, E, B bar and B. Okay. In the place of, in the place of, wait. What I have taken here, J, right? Coming to J, right? Coming to J, either we can write it is E bar by E or B bar by B. Okay. It is our choice. Next. And next, see what is left here. K cap. See, in the place of K cap, what we can write? K cap. K cap is equal to I cap cross J cap, right? It is I cap cross J cap. Then we can write it is V naught bar cross B bar divided with modulus value V naught B. This is giving us K cap. Or the same thing I can write because E bar and B bar both are parallel. Okay. So I can write same thing as V naught bar cross E bar. Okay. Upon V naught E. Right. So here what we are focusing is we want to get K cap. How to get it? So velocity along I cap, field along J cap. So I cap cross J cap, K cap, divide with the modulus value. We get K cap. Or same thing I can write in the place of B bar, E bar. So anything is same. So in the place of I cap, in the place of J cap, in the place of K cap. Right? That is our final answer. Okay.